Today we're going to look at finding roots of quadratic functions using multiple methods, and then also showing that equation with multiple representations. And so we're going to start by looking at our function. So our function is located right here in this center box. It's x squared minus 9. And the first thing we want to do is see if we can solve by taking square roots. So if we rewrite the function here, and then our first step when it says to solve means to substitute 0 in for f of x or for y, and then solve for x. So we'll add 9 to both sides, which will give us 9 equals x squared. Then take the square root of both sides, which will show that x is going to be plus or minus 3, because that's our square root of 9. And so when it says solve by taking square roots, that's what we want. So our solutions down here are x equals 3 and negative 3. That's where we'd put our solutions. Okay, then it says solve by factoring if possible. And so it's kind of the same thing. We'll rewrite that expression. This is the difference of two squares. It's a perfect square binomial, and so we have a factoring pattern for that. It's going to be x squared, x times x minus 3 times 3. So we'll write in x plus 3 times x minus 3 and set that equal to 0. And then we'll use the zero product property to set each one of these factors equal to 0. Because the product will be 0 if either factor is 0. So we'll have x plus 3 equals 0 and solve to get x equals negative 3. Then we'll have x minus 3 equals 0, solve for x equals positive 3. And again, we find our solution should be the same as before, 3 and negative 3. Next, we can graph our function. So x squared minus 9. So this is our y-intercept. And so 1, 2, 3, 4, 5, 6, 7, 8, 9. Our stretch factor is just 1. A equals 1. This is also our vertex. It's just x squared minus 9. So it's the x squared function translated down 9 units. And so our vertex is actually here at 0, 9. If you weren't sure, you could try to substitute, you could try to solve for h and k. But b here is actually equal to 0. And c equals 9. If you were trying to solve for your vertex, you would find your h value by negative b over 2a, which in this case would just be 0 over 2, which is 0. And so our h coordinate is actually the y-axis. And so that just becomes our vertex. Okay, then a is our stretch factor. It's just 1, so there is no stretch factor. We just follow our regular pattern from the vertex of over 1, up 1, over 1, up 3 in both directions. And then we sketch in that parabola, trying really hard not to make a point at the vertex, but a curve through the vertex. Okay, but we need to solve. And so actually we need to, it says solve, right? Not just plot. So let's extend that a little bit here. We went over 1, up 1, over 1, up 3, over 1, up 5, which should put us very nicely at positive 3 and negative 3. I forgot what we were doing for a second. I was just plotting my parabola, but we're solving. And so again, we get 3 and negative 3 for our solutions here. And let's go ahead and show some values on our axes, negative 9, 3, and negative 3. Then the quadratic formula. So that's the thing we're introducing today. Many of you have seen this before. This is the formula, and it's taken from standard form of the parabola. So in this case, again, a is 1, b is actually 0. We don't have an x term. So this is like x squared plus 0x minus 9. And that would mean c is negative 9. Okay, so we'll just put these values into our function. So we see that x equals the opposite of 0, which is this 0, plus or minus the square root of b squared, which again, 0, minus 4 times a times c all over 2 times a, which was 1. So it's a lot of PEMDAS here. So this 0 in the front really just simplifies away. And so we'll just see this as a plus or minus the square root of. And let's simplify this in here. 0 minus a number, well, we've got 4 times 1, which is 4, times -9 is -36. We're subtracting -36, or we just have a positive 36 inside our parentheses. And we would divide that by 2. The square root of 36 is 6. So we'll have plus or minus 6 over 2. And we're actually going to solve that. We're going to have plus 6 over 2, or we have minus 6 over 2. Okay, I'll even put a plus there just to emphasize that. And again, we're getting 3 or -3. So x equals 3 or -3. So we've shown that 4 different ways to solve. For this particular function, you could solve it all 4 ways. Sometimes it's, if you get something in standard form, you might not be able to solve by taking the square roots, or it might not be factorable. So that's why we have this if possible and if possible. But you can always graph it. You may not be able to solve by graphing if it has complex roots, but if it has real roots, you can solve by graphing. Just see what those x-intercepts are. And then the one thing that always works for real roots and complex roots is our quadratic formula. So that's always going to work. Okay, so then we're also asked to rewrite this function in vertex form. Well, guess what? We learned up here that h was equal to 0, right? We also know that a equals 1 from the original equation. It's always the same a. But what is the value of k? Well, it turns out that k, we can see our vertex is at 0 and 9, and k, 0 and -9. K is -9. And so we'll just plug in these values here to get f of x equals, we won't show the 1. We don't need to show that. X minus 0. X minus 0 squared. Okay, and then minus 9. Well, x minus 0 is just x. So this becomes x squared minus 9. And you might say, hey, that looks just like the original one. And that's true. So the original function, I've been talking about it as if it was in standard form. But guess what? It's the same as vertex form. When h is 0, standard form and vertex form look the same. And then factored form, well, we did that up here when we factored it. And so f of x equals a again is 1. We don't need to show that. X minus 3 and x minus -3 or x plus 3 for factored form. So these are 3 ways to write that function. Okay, so that's one example. This is one video with one example. I'm going to put in a second video that has a value for b that's a more complicated function in standard form, and then we'll have to do all these things with it.